Alright, good afternoon. Let's take a look at matrices. This is module 3, and we're going to do PA5 as part of it, and you'll end up submitting that diary file as your PA5. We want to talk about how you do matrices, which as far as MATLAB is concerned are arrays, but we also want to talk about using them mathematically. So an array is m rows and n columns of data. A matrix is m rows and n columns of numbers. We set it up just the way we have been. Elements separated by commas or spaces, rows separated by semicolons. So you can see all those go in the first row, semicolon in the second row. If I want to talk about an individual element in an array, we call array dressing or indexing. And the index would be 1, 3, row 1, column 3. So that'd pick out 13. If I want to pick out more than one element, I can give it a range, and if I give it a blank range, then it gets all of them. So A, if that's A of colon comma 2 is going to be all of the rows, column 2. So that's going to be both of those. Flip it around, 2 comma all is going to be row 2, all the columns. So that'll pick out a row. Now, in math, linear algebra, or maybe pre-cal, if you've dealt with matrices, you know how to add them up. You know they have to be the same size, and you go element by element. And if we did multiplication that way, if you do a dot multiply, it will do it that way. But that's not how we do matrix multiplication mathematically. It comes out of solving systems of equations. So here's a system of equations. 2 equations, 2 unknowns. Put all the variables on one side with the same order of the variables and the constants on the other. And then you have your coefficient, 2, 3, 1, 1. You've got your variable, which is a column, and your constants, which is a column. And then it reproduces the equation by multiplying row by column. So 2x, 3y equals 7. 1x, 1y equals 3. Multiply row by column, add as you go. So to illustrate that a little further, here's 2. We got 1 row, 1 column. You go across it down, so 1 times 4 plus 2 times 5 plus 3 times 6. Add them up and you get a single number, 32. So a row times a column. They're going to have the same number in the row and the column to match, and it'll give you a single number. So here I've got, notice that's a 1 by 3, 3 by 1, answers a 1 by 1. Here I've got a 1 by 3, 3 by 2, 1 by 2 is going to be my answer. Row times column, so 1 times 3, 2 times 2, 3 times 1. Then you move to the next one, so you go 1 times a minus 4, 2 times a 5, 3 times a 6. Add them up as you go, 1 multiply, and then you get 10 and 24. So here's one. I want you to probably pause the video, do it by hand, and then once you check it, then we'll check it in MATLAB. You start a diary file. So 2 by 3 and a 3 by 3, row by column. Give it a shot, and I've got the answer on the next slide. Here it is. So you're going to go 1 times 2, 0 times minus 2, 3 times minus 1, and then you're going to go to the next row. Next column. 1 times a minus 3, 0 times 4, 3 times 0. Then we take the same row, next column. 1 times 0, 0 times 1, 3 times 1. And so that'll give us 3 numbers in the first row. Then we go to the next row and do the same. 2 times 2, 1 minus 1 times minus 2, minus 2 times minus 1. Add those up to give an 8. Then the next column, 2 times minus 3, minus 1 times a 4, minus 2 times a 0. Add those up, get a minus 10. Then the last column, 2 times 0, minus 1 times 1, minus 2 times 1. So, as we said, you get a 2 by 3. Now try to do that in MATLAB. And if I might go through it once and then go back and do it again with the diary file. But check that. Make sure you can put those 2 matrices in and multiply them. Okay, I think I might have done that over here in MathCAD. Let's see. Yeah, so there's my A. Well, no, I guess that wasn't this one. Sorry about that. Let's keep going. So, do your check. Okay. Now, not all of them can be multiplied. They have to be the right size. So, n by n, the number across and the number down have to equal. So, n by n times n by p, those inner ones have to be the same. The outer ones are your answer. 2 by 2 is going to give 2 by 2 will give me a 2 by 2. But notice that some of them, if you swap, they're not going to be the same size. We say they're non-conformable, or even if they do, A and B, you want to work out different. This is maybe for some of you the first mathematical operation you've seen that doesn't commute. Matrices in general don't commute under multiplication. Now, to develop the matrix algebra that we're going to use to solve systems of equations, we have to understand the equivalent of the identity element. The identity element for multiplication is 1. It's whatever you multiply a number by and get yourself back. The equivalent for a matrix, because of how we define the multiplication, is 1's on the diagonal, 0 everywhere else. So you can see 2 times 1, 3 times 0. It'll give you 2 back. 2 times 0, 3 times 1, etc. And so if you multiply by I, you're going to end up with the same matrix. So I is special. I does commute on a square matrix. Now, we also need to have the inverse element. In other words, there should exist a matrix that you multiply by that will give you I, similar to 2 times a half is 1, right? It's simple division for real numbers and multiplication, and matrices are much more complicated, so it's not trivial. 2 by 2s, with a little practice, you can write it down, but past that, that's what you'll learn to do in linear algebra, or you may have already in pre-cal. But you can ask the question, are 2 matrices inverses? So here's one. I'll multiply them out. And indeed, they're 1, 0. So they are inverses of each other. This one's the inverse of the first one. That one's the inverse of the second one. Are these 2 inverses? Well, what I want you to do is multiply it by hand. So you might want to pause this, multiply it out, and then I want you to check it in MATLAB, and that needs to go in that same diary file that the other one did. Row by column. I'll let you check that on MATLAB. Turns out they are. I think I did do that on MATLAB. Yeah, there it is. There's my A, there's my B, multiply them together. If they're inverses, it turns out they do commute, so I can go B times A, and it'll also be. Okay? Oops. Now the logic is, I don't really go back, but if I've got a system of equations and I write it in matrix form, then if I multiply on the left by the inverse, multiply both sides of the equation by the same thing, then that will give me the identity element, I, and I times that one will be x. So just like if it were 2x equals 3, divide both sides by 2, similar, multiply the inverse, but it's not simple division. And you'll find that the solution to the system equation is A inverse C. So for our example, our A inverse was this. That was our C. Multiply them out and we get 2 and 1. And if you plug that back into our equations, you'll see, yes, indeed, that is the solution. The way you calculate the inverse in MATLAB of a square matrix is just I and V of A. You can store it in another matrix. So that's the last thing I want you to do. That'll be PA5. You can close PA5, and now you're going to be ready for PA6. Let's see if we can talk about that for a second. Let's go over here. Now let's go here. Yeah, PA6, I give you a system of equations, and I want you to go through that process to solve them. Now, I also have a by-hand assignment, if you will, that I want you to do. This will count as a quiz. You might want to do it before you do PA6. The instructions are here. The idea was for you to write it out on paper and take a picture and send it in, and you can check your stuff on MATLAB. If you want to do it all in MATLAB, if you feel comfortable enough in MATLAB enough to do that, then go ahead and send me a diary file that contains all those problems. Either way, that's going to go in and count as a quiz. So do that one also. All right, I'll see you in the next video. How can I stop it? Instructions are hiding. Ah, crap. I can't get it to quit. There it is.